Hi everyone, welcome to this video where we will learn about how to plan and design the databases on AWS. So before we begin with today's video, let me give you a little bit introduction about myself. My name is Aishwarya Sood and I am working as a lead coach into the AWS domain. I am 3x AWS certified, AWS Academy accredited educator, also an Amazon authorized instructor. You can connect with me on LinkedIn. The profile name is given here, Aishwarya Sood 29, and you can also scan this QR code to directly view my profile. So the agenda for today's topic will be, we will start with discussing the types of databases that are available, basically the relational and non-relational databases, then the database options available that are available on Amazon, and the criteria for choosing a database, then what's the difference between unmanaged and managed databases, and when to use what. Then we will discuss a little bit about Amazon RDS, Amazon Aurora, DynamoDB, Redshift, and a few other purpose-built databases, so that you can decide which database to choose for your workload. So let's get started with the first topic for today, the types of databases. So many of you would have heard about and worked much on the relational databases, but maybe less on the non-relational ones. For decades, the predominant data model that was used for application development was a relational data model itself, and that is used by relational databases such as Oracle, SQL Server, MySQL, and PostgreSQL. It wasn't until the mid to late 2000s that the other data models began to gain significant adoption and usage. To differentiate and categorize these new classes of databases and the data models, the term NoSQL was coined, and often the term NoSQL is used interchangeably with the non-relational. So you see sometimes it would be written as NoSQL or sometimes as non-relational. A relational database works with the structured data that is organized by a table, records, and the columns, and the relational databases establish a well-defined relationship between the database tables. Also, they use the structured query language, or the SQL, which is a standard user application that provides programming interface for the database interaction. And the database schema is fixed in these kind of databases, as you can see on this example also. The 2 rows, 4 columns, and that's it. For the both the entries, it's the same. But talking about the NoSQL databases, they are highly available, they are scalable and optimized for higher performance. And instead of relational model, NoSQL database use alternate models for the data management, such as key value pairs or the document storage or even the graph databases. In these databases, the schema is entirely flexible. The rows can have different attributes, and this model can work with the unstructured and semi-structured data as well. So let's say the first row will have 4 columns, maybe the second row will have just 1 column, the third row will have the data in 2 columns. So this is possible in the NoSQL databases. Some traditional examples for the relational databases include Microsoft SQL Server, Oracle Database, and the MySQL, whereas some of the traditional examples for the non-relational databases include MongoDB, Cassandra, and Redis. So now that you learned about a few distinctions between the relational and the non-relational database, we can see some examples for the offerings of the databases that are available by Amazon that fit into these two categories, the relational and the non-relational. Among the more commonly used AWS relational database offerings are the Amazon RDS, Redshift, and Amazon Aurora. And similarly, some of the more commonly used non-relational databases are Amazon DynamoDB, Amazon Elastic Cache, and Amazon Neptune. So we are gonna discuss about a few of them in today's video. Relational databases are sometimes referred to as a relational database management system as well. So that is the RDBMS, and they are still the single most popular and most used database category in the world. Also, in a study in 2019, that was a DB Engines ranking study, they were found to represent over 75% of the popularity score across all the categories. The top 4 were Oracle, MySQL, Microsoft SQL Server, and PostgreSQL, which are all the relational relational databases. So there are a lot of benefits of using relational databases because they use a common SQL language to query over the data, and they are ideal when we need the strict schema rules for our data. We do not need extreme read write capacity, but it's like kind of moderate in just few thousands only, and we do not need very extreme performance also. We are okay with the moderate one. And the relational tables, you can see this is how the relational databases look like. There are multiple tables, they are all having the relations to each other. Okay, so this is how the relational ones look like. So when we talk about the non-relational database types, they are also called as NoSQL databases, as I told you a few minutes back, and they are different from relational databases because they are purpose built for specific data models and have flexible schemas for building the modern applications. Non-relational databases are like widely appreciated for their flexibility and scalability and the high performance. So whenever you see that you need flexibility, the answer should be a non-relational database only, because in relational we don't get that kind of flexibility, because this non-relational databases use a variety of data models including key value, graph, document, in-memory and the search as well. These schemas are dynamic, and for example, a row does not need to contain the data for each column. Also, the NoSQL database can scale horizontally by increasing the number of servers that it runs on. The flexibility, the scalability also is a good thing here. Also, they can store the structured data such as relational database records, semi-structured data such as JSON documents, and unstructured data such as photo files or the email messages. So they work well when the data might have the structural inconsistency, and non-relational databases are optimized for specific data models and access patterns that enable higher performance instead of trying to achieve the functionality of relational databases. So they will be more ideal. They will be more ideal when you have the requirement to scale horizontally. The database must scale horizontally because the data volume is huge. We have lakhs of reads and writes per second, and the data is such a way that it is not lending itself to the traditional schemas that we had in the relational databases. In such cases, you can consider going for any of the non-relational database type. So as an architect, we will have to think about a few things before choosing a database. Few factors like scalability, total storage requirements, object size and the type, and the durability. So we will be asking a few questions to ourselves before we choose a database. First thing will be about the scalability. With the traditional on-premises databases, scaling up capacity can be a little difficult task even for the experienced database administrators, because it can take hours, days or even weeks. And if you under-provision your database, your applications might stop working. However, if you over-provision your database, you increase your upfront cost by procuring the resources that you do not need, and which violates the cost optimization principle of the AWS well-architected framework. So ideally, you should choose a database solution that has the resources to handle the needed throughput at launch, and that can also be easily scaled up later if your throughput needs increase. So once you have the answer to this question and you have a database in hand after you have thought about this, then you are good to go for the next requirement. So next will be the storage requirements. When you must choose a database to handle a certain type of workload, consider these storage requirements for the workload. How large must the database be to handle your data requirements? Does it need to store gigabytes, terabytes or the petabytes? Accordingly, you can choose a database, because different database architectures support different maximum data capacities. Next will be to check the object size and the type. When you choose a database for your specific workloads, you have to consider the size and the type of the objects that you are going to store in the database. Do you need to store simple data structures, large data objects, or maybe both? Apart from this, one more thing will be durability. Durability of the data will be referring to the assurance that your data will not be lost, and data availability refers to your ability to access your data when you want to. So what level of data durability and data availability do you need? If the data that you will store is absolutely critical to your business, you should choose a database solution that stores multiple redundant copies of your data across multiple geographically separated physical locations around the world, and this solution will usually result in an increased cost. So it is important to balance your business needs with the cost considerations. Another important consideration is to know whether the data residency or regulatory obligations apply to your data. For example, are there regional data privacy laws that you must comply with? If so, choose a database solution that can support the compliance. So for hosting your databases, you have got three options here. Let's have a look at the differences between all these options. One, we can host the databases on our on-premises, where we have to take care of everything. We manage everything starting from the underlying hardware to the application optimization. All is our responsibility. Second, we can host a database on an unmanaged service in AWS, that is on Amazon EC2, where few of the things will be taken care by AWS, but still majority of the things are being taken care by us, starting from the operating system, patches to the scaling, high availability backups, and the application optimization we have to manage. Still, we have so much of work to do here. The third thing is to host a database on a managed AWS database service, where, as you can see, we don't have to take care of these things at all. They all will be managed. We just have to take care of the application optimization. That's it. That means we can get more time to focus on application optimization rather than the administrative tasks. We won't be spending our time and efforts on that. So it depends on you basically, that if you need more control, you can go for Amazon EC2. If you need more convenience, you can go for the managed database service. So before we begin with discussing different databases, let's ask a few questions from ourselves. Do you need an unmanaged relational database solution? Do you want to control the operating system and the underlying infrastructure for your relational database? And are you okay with patching the operating system and handling all the software and backup operations on your own? If you have the answer as yes to all of these questions, the answer is host a database on Amazon EC2, because you will get all the control over here. You will get to do all these things that were mentioned here. So the solution will be to hosting a database on Amazon EC2. So let's go to the AWS console and let's see how we can host a database on Amazon EC2. So I'll quickly launch an EC2 instance for hosting our database onto it. Let me give a name to it, my DB server, and I will say AMI. I'll go ahead with the default Linux to AMI, that's fine. T2.micro EC2 instance is also fine. Let me select a, or let me proceed without a key pair itself, and no specific preferences for the network, and storage is okay. Let me check if we need to configure anything else, or else I will go ahead and quickly launch my EC2 instance. So nothing needed as of now. I'll quickly launch the EC2 instance and we will host our database onto it. So my EC2 instance is getting ready. Let me refresh. So it is into the pending state. Let me wait for it to come to the running state. I'll connect to it and I will host the database onto it. So my EC2 instance is into the running state already. That means I can connect to it, and from the instance connect option itself, I have connected to my EC2 instance. And what I'll be doing, I'll be installing a MariaDB engine on my Amazon EC2, and from there on we can continue working on the database. So I have the commands ready which are needed to install the MariaDB on my EC2 instance. You can have a look at these commands. I'll quickly run these commands and install the MariaDB. So for launching your DB instance, for hosting your database also, you can use the same commands. So I have run all the commands to save time. You can see all the commands have been processed, and now what I'll do, let me just reconnect to it. I'll just connect to my MariaDB database. Let me enter the password that I set. 1 second, I'll enter it again, and you can see I have entered the password, the username was root, and the password also I have entered. Now I am into my MariaDB database I have hosted, that I hosted here. So I can run the commands like show databases. You can see these databases are currently there. You can use all the commands for creating databases, for creating tables, inserting data, selecting it, deleting it, similarly how you work on a normal relational database. So now you can run all the commands over there. So that was the simplest way of hosting your database on Amazon EC2. We will see a few other databases also, like how we host a database on RDS and with the DynamoDB as well. So for now, let's get back to our slides and let's understand the next type of database. Now you ask yourself a few more questions, that do you need a managed database solution? Do you need strict schema rules and a fixed design? And is your data complex with a lot of relations and joins to multiple tables? And do you have few thousands of reads and writes per second? If you say yes to these questions, the answer will be Amazon RDS. Okay, so about RDS, let's discuss a few things. First of all, it is a fully managed relational database service by AWS that makes it easy to set up, operate and scale a relational database in the cloud. It's very easy to set up. I will show you on the AWS console. It provides cost efficient and resizable capacity while also managing the time consuming database administration tasks. By using RDS, you can focus on your application and businesses because the administrative tasks will be automatically handled by the service itself. So the basic building block of Amazon RDS is the database instance. A database instance is an isolated database environment that can contain multiple user created databases, like how we create the EC2 instances in the EC2. Similarly, we create DB instances in the RDS. It can be accessed by using the same tools and applications that you use with the standalone database instance, and the resources in a database instance are determined by its database instance class, and the type of storage is dictated by the type of disks. Also, RDS provides you with 6 familiar database engines to choose from, which includes Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle database and Microsoft SQL servers. This means that most of the code, applications and tools you already use with your existing databases can be used with the Amazon RDS as well. One of the most powerful features of Amazon RDS is the ability to configure your database instance for high availability with a multi-AZ deployment. After a multi-AZ deployment is configured, RDS automatically generates a standby copy of the database instance in another AZ within the same VPC. And after seeding the database copy, transactions are synchronously replicated to the standby copy. And running a database instance in a multi-AZ deployment can enhance the availability during planned system maintenance, and also it can help protect your database against the database instance failure and the AZ disruption. So if you want high availability, you can very well go for the multi-AZ, but keep in mind the cost will be double because there you will be having 2 database instances. Then RDS also supports the creation of read replicas for MySQL, MariaDB and PostgreSQL and Amazon Aurora. Updates that are made to the source database instance are asynchronously copied to the read replica instance, and you can reduce the load on your source database instance by routing the read queries from your applications to the read replica. Okay, so that the primary database instance is just having the write queries and all the read queries are taken care by the read replica itself. The another thing is that read replicas can be created in a different region than the primary database. Also, we can create up to 5 read replicas. Last thing, you can choose to create a storage volume snapshot for your database instance, backing up the entire database instance and not just the individual databases. It can be a manual snapshot or an automated snapshot as well. So these few things, if you keep in your mind, you will be able to know when to go for Amazon RDS. Here is a simple application stack that you can see right now. This application is running on an EC2 instance, and it is supported by a primary database that is running in an Amazon RDS DB instance. Placing the EC2s behind a load balancer lets them have the even distribution of the traffic. So the request will be coming from all the users. It will be received by the load balancer, which will distribute them evenly to the underlying EC2s, which will process the request, and any data that needs to be sent will be sent in the RDS instance that's there, and any snapshots that you are taking from the RDS instance will be kept in the Amazon S3. So before we ask other questions to choose another database, let's have a look at how do we configure the Amazon RDS on the AWS console. Let's go back to the AWS console. We will set up a RDS database now. So here we are into the RDS console. What we have to do is just go to this DB instances and let's say create database. So we get two options over there when we click on create database. One is standard create, one is easy create. Easy create, you can choose when you want that all the defaults will be selected, all the default settings will be given according to the best practice configurations. So you don't have to configure much, just select this and click on create database for a quick create. Okay, but when you want to customize a few settings and to define according to your requirements, you can say standard create, and you will see a lot of things will be coming for you to configure. So for this demo, let's go with the standard create itself so that I can explain you different settings. First, we have to select an engine. We can choose from Amazon Aurora, MySQL, and all the engines that are given over there. I'll go ahead with the MySQL as of now, and then we will see the version. It will be by default selected the latest version, and you can also select a older version if you need. Then templates. If you choose a production template, it will choose all the default settings that are according to the high availability, fast and consistent performance. You can see multi-AZ will be selected and other things also according to the production. If I go with the dev and test, if it means all the defaults for the dev and test workloads accordingly will be selected, which means multi-AZ will not be selected, it will be just a single DB instance. If I select free tier, then it will select all the default settings which are coming under the AWS free tier. So for this demo, we will go ahead with the dev and test environment. Here you have to just give a name to your database instance. Here you give a master username. It can be admin. Okay, the by default is admin. You can give root, admin, master, something like that you can give. Then you have to give a password for that. So after giving the password, where you will be using these credentials to connect to your DB instance. Then you have to select the DB instance class. Okay, you can select, let's say we will select the T classes, the burstable classes. We are okay with the db.t3.micro, which contains 1 GB of RAM and 2 CPUs. That's okay. And then you select the storage type. By default, it is general purpose SSD and the 20 GB, which is minimum. Maximum can be 16 TB. Because the underlying storage volume that is getting used is the EBS volumes. So you can choose if you want to change from here. I'll let it be default only. No auto scaling needed as of now. Multi-AZ deployment was about to be configured from here. Since I have selected the dev and test template, that means it has said do not create a standby instance. So only for the production usage it is recommended to create a standby instance. Okay, then in which VPC I want to keep my RDS DB instance, I'll go ahead with the default. Subnet group also, let it be default itself. Then, do you want the public access for this RDS DB instance or not? If you say no, then no IP address, no public IP address will be assigned to your RDS DB instance, and only the EC2s that belong to the same VPC can connect to your RDS DB instance. But if you say yes, then the Amazon EC2 instances that are residing outside of the VPC in which your RDS database instance is located, they can also connect to your DB instance. So for this demo, I'll go ahead with the default no itself. Choose the security group that you want to use with it. Right now it is selected default, but you will be adding the appropriate rules to the security group and then selecting, so that it allows the inbound and outbound traffic appropriately for the MySQL traffic. Do you have a preference for the AZ? You can choose from here. Otherwise, you can say no preference, so that in any AZ it will be kept. Apart from this additional configuration, what do you want to give? You have to give a name to your database, let's say I'm giving DemoDB. Okay, and automated backups I don't want. I'll be disabling all the things like encryption, backups, enhanced monitoring, because for this demo I don't need all of them. So I can go ahead with the creation of the database now. So you can see, based on the selections that I have made, the approximate cost will be $20.87. If I change the configurations, this approximate cost also will be varying. So I'll go ahead and click on create database, and my database will start the creation of it. So it is right now into the creating status. You can see it will take around 10 to 12 minutes to become available. So once it is available, we can go ahead and connect to this database instance from a local machine also, and from the EC2 instance as well. So we can do both of them. In this video, we will be connecting to our DB instance from the EC2 instance that we created. From the same itself, we can connect to our this DB instance that is getting created now. So I'll wait for the status to become available. I'll pause the video here, and we will get back to the to connecting the DB instance from our EC2 once it becomes available. So my database is now into the available status. That means we can connect to this database instance. Let me show how it looks like, what all details are there. So we have got the endpoint which we will be using to connect to our database instance, the security group that we used, the subnets, and everything. All the details are available here. If we click on monitoring tab, we can see all the details about the monitoring here. There are no connections as of now. Entire storage that is provisioned is pending, that we can use, okay, for our purposes. Then no write IOPS, read IOPS, nothing as of now, because we have not used it. So what we will do now, we will go ahead and connect to this DB instance from our EC2 instance itself. I need to copy this endpoint, and I will connect to this DB server that I created previously. So the command that we need to run is this mysql -u, that was admin, if you remember, -p for the password and -h for the host name that we have just copied. So let's press enter, and let me enter the password here, and you can see, yes, I am here connected to my database now. So now it is a MySQL database that we have created in the RDS DB instance just previously. So here also, if I run this command, show databases, you can see these are the databases that are available right now into my RDS database. Okay, so we have seen two ways of hosting our database. One on the Amazon EC2, which is unmanaged, one on RDS, and how to connect to this database from our EC2 instance. Now next we will be going back to the slides and discussing about different type of database. Now ask yourself a few more questions. Do you need very high availability for your relational database? Do you need the support for more read replicas? And do you want global tables and serverless features also for your relational database? Then the answer is Amazon Aurora. So what is this Amazon Aurora? Let's have a look at the few important points about it. It is a fully managed database service and is designed to automate the time-consuming tasks like provisioning, patching, backup, recovery, failure detection, repair, and it combines the performance and availability of high-end commercial databases with the simplicity and cost-effectiveness of the open source databases. It is designed to be highly available because it stores multiple copies of your data across multiple AZs in a single region. Okay, so you can just imagine like you are storing somewhere in something in the Amazon Aurora, and it is keeping 6 copies of your data across multiple AZs within the same region. That leads towards a big high availability. And about read replicas, if you remember, we can have just 5 read replicas in the previous DB engines that we discussed. With Amazon Aurora, we can create up to 15 read replicas, which can help to reduce the possibility of losing the data. And it is up to 5 times faster than the standard MySQL databases and 3 times faster than the standard PostgreSQL databases. Also, it is designed to have the drop-in compatibility with the MySQL and PostgreSQL database engines, so that you can use most of your existing databases tools with little or no change. Also, we have one more option, Aurora Serverless, which is an on-demand auto-scaling configuration for Amazon Aurora. So what it does is it automatically starts up, shuts down and scale capacity up or down based on your application's live needs, and it enables you to run your databases in the cloud without managing any database capacity. You won't have to create the database instance in this case. Okay, you just specify the capacity for this kind of offering by something known as Aurora capacity units, which will determine the memory and other capacity for your database server. And then we have one more feature with Amazon Aurora, Aurora Global Database, which is designed for globally distributed applications, allowing a single Amazon Aurora database to span multiple AWS regions itself. It replicates your data with no impact on the database performance and also enables fast local reads with the low latency in each region and provides disaster recovery from region-wide outages, so that your customers all across the world have the low latency for the database responses. So these are all the amazing features available in Amazon Aurora. This is a flagship offering in the category of relational database engines by Amazon Aurora itself. Next thing to ask yourself, let's move towards the non-relational databases now. So ask yourself a few questions like, do you need a serverless database solution? Do you need a non-relational database? Do you want extreme performance, ultra low latency and extreme scalability in your database? Is your data simple but has very large number of reads and writes per second? Then the answer is Amazon DynamoDB. So let's understand a few important things about DynamoDB. So first of all, it also is a fully managed NoSQL database service, and the complexity of running this massively scalable distributed NoSQL database is managed by the service itself, since it is fully managed. This allows us software developers to focus more on the building of applications instead of managing the infrastructure. And it is serverless, means no servers to provision, patch or manage, no software to install, maintain or operate. You just pay for whatever request it serves. That's it. Whenever it is idle, that has no effect on anything. And that is the next point itself. So it is cost effective because of the point I just mentioned, that you pay for the storage you are consuming and the IO throughput that you have provisioned. Okay, since it is serverless and event driven, which means only when there's a request that is being served by DynamoDB, we pay for that and a few other storage things. And it is designed to scale elastically while maintaining the high performance. It offers consistent single digit millisecond response time, and you can build applications with virtually unlimited throughput when you are talking about Amazon DynamoDB. And as it provides ultra high throughput and low latency, so it is a good option for gaming, ad tech, mobile and other applications that have these requirements. Also, the items can have different attributes, which I told you previously also, that each row in the DynamoDB table can have different attributes. And DynamoDB has a feature of global tables that enable you to automatically replicate across your choice of AWS regions. So this is basically for multi-region, multi-master DynamoDB table. Okay, so that you can have your master database available across multiple regions, like how we have this feature in Amazon Aurora also. Then DynamoDB works well for the applications that handle a high volume of data. Okay, the data is simple but and also the temporary, but the volume is high. For such applications you can very well go for DynamoDB. Let's have a look at a few examples for this. You can see a very simple application architecture where again the user requests are coming for our application and it is received by load balancer, and which is forwarded to underlying EC2 instances and distributed evenly among them. And for the database they are using the DynamoDB. So all the data is getting stored in the DynamoDB over here. And then another case for the game leaderboard. So game makers can support simple leaderboards by using DynamoDB. One such use case is the ability to display the top scores for a game. If a gaming company already stores a player's game states in DynamoDB, including players' top scores, the ability to get the top scores can be implemented by using a global secondary index feature that is available in Amazon DynamoDB. So that can be discussed later on. You can, as of now, you can understand that for such cases when the data is temporary and is high volume, you can go for DynamoDB. Another case can be online shopping cart data. So we all know what kind of data gets stored in the online shopping websites cart. When we, let's say when we go to Amazon and we browse through the products from the web store and we keep adding the things into the cart. Those things in the cart will have different attributes. Some products in the cart will be having name, size, color, quantity, while other product might be having just name and quantity. Okay, so that data is flexible, they have different attributes, and that data is temporary because I'll be adding or removing the objects frequently. I'll be just checking out. Okay, once I am done with the product selection, I'll be checking out. So that data is not going to stay for a longer time in the cart. Also, it has different attributes, so all that leads towards that DynamoDB will be a good choice for such data. So let's have a look at how we can configure our DynamoDB tables on the AWS. So I'll go back to the console and let's search for DynamoDB. Here I am into the DynamoDB console, and let's say we want to create a table. So I just have to give a table name. Let me say sample table or sample. Okay. Partition key is nothing but a primary key which will be uniquely identifying the rows in the table. So partition key name, I will say this can be kept as singer, and I will add the sort key also because one singer might have multiple songs sung by him. So we can sort all the songs sung by him using this sort key. I will say song name, let it be the sort key. So settings, let it be all the default settings, and quickly create a table. And here I can see my database is ready, it is active and it is ready to use. So let me click on this and you can see all the things configured here. And we will add few items into our DynamoDB table now. So for that we need to click on actions and let's say create item. Singer, let's say this is singer 1 and song name is first song. Okay, we can even add new attributes, whether string, number, boolean, binary, anything we can add it here. Right now I'll not add those things and I'll quickly create the item. So since I have mentioned both the partition key and the sort key, which means the same key can be written again. Let me show you how. Like let's say singer 1 again, and song name will be different this time. So the song name will be second song this time. Or if you would have done that singer 1 same thing as previous, first song same thing as previous, then it would not have let you add this, because the combination of singer plus song name should be unique all across the table, because this is a partition key plus sort key. So I'll create this item. This also has been added. Now let me check the items from here. So before we explore, we will add 2-3 more items here. Let me add more item. Now this time I'll be adding singer 2 and the song will be, let's say song 1 and create item, and I will say more item, let's say one more item we will create, singer 3 and song name is first song again. So if you remember, this song we have added for the singer 1 also, but it will let us create that because we have added the partition key and sort key. Okay, so that's why this repetition is allowed. Otherwise if we have given only partition key, then it would have been the different case. So let's explore our items and we will see what all data is there as of now. You can see singer 1, singer 2 and singer 3, all these things are there. So how do you fetch them? One is scan operation, which will fetch all the items from the table. One is query operation, where we can query the data by mentioning the partition key. Let's say I will say I want to fetch all the data that is there for the singer one, and sort key also optionally I can mention. So sort key, I will say it is first song, and then I will run it. So you can see only one item has been returned. Totally there were 4 to 5 items that we added into our table, but right now since I have mentioned the specific things, that's why it only returned the appropriate result. So this is query can be used when you want specific results out of it. Scan can be used when you want to fetch all the items. Okay, so you just run it and you can see all the items have been returned here. So this is how you can work with the DynamoDB. So we have seen 3 different ways of hosting our database, one on EC2, one on RDS, and now on the DynamoDB. Proceeding towards the next thing, we have to ask a few questions now again. Do you need a data warehouse solution? Do you need a cost-effective solution to analyze all your data? And is your current data warehouse solution complex and expensive? The answer will be Amazon Redshift. So I hope you all understand a little bit about data warehouses before we begin with this Amazon Redshift. So analytics is important for businesses today, but building a data warehouse is complex and expensive. Data warehouses can take months and significant financial resources to set up, but Amazon Redshift has got the solutions for you. It is a fast, fully managed, powerful data warehouse that is simple and cost effective to set up, use, and also scale. It enables you to run the complex analytical queries against petabytes of structured data by using the sophisticated query optimization, columnar storage on the high performance local disk, and massively parallel data processing. And most results come back in seconds itself. And Amazon Redshift is compatible with the tools that you already know and use. Redshift supports standard SQL. It also provides high performance JDBC and ODBC connectors, that is Java database connectivity and the open database connectivity connectors, which enable you to use the SQL clients and BI tools of your choice. Also, it is straightforward to automate the most of the common administrative tasks to manage, monitor, and scale your Redshift cluster, which enables you to focus on your data and your businesses. And scalability is intrinsic in the Amazon Redshift. Your cluster can be scaled up and down as your needs change with a few clicks in the console itself. So many use cases can be there. It can be used as an enterprise level data warehouse. It can be used for the big data customers because they will have one thing in common: massive amounts of data that stretch their existing systems to a breaking point. Smaller customers might not have the resources to procure the hardware and expertise that is needed to run the systems, but with Redshift, smaller customers can quickly set up and use a data warehouse at a comparatively low price point. Also, the software as a service applications customers can take advantage of the scalable, easy to manage features that Amazon Redshift provides. Some customers use the Amazon Redshift to provide the analytical capabilities to their applications. Okay, so that's about the Redshift. Apart from this, we will discuss a few more purpose-built databases. We will not dive deep into them, but just a few things I will tell you about them. Do you need a graph database? You can go for Amazon Neptune for the use cases like fraud detection, social networking, and recommendation engines. If you need a document database, you can go for Amazon DocumentDB for the use cases like content management, catalogs, and user profiles. And if you need a time series database, you can go for Amazon TimeStream for the use cases like IoT applications, DevOps, and industrial telemetry. And if you need a ledger database, you can go for Amazon QLDB, that is Quantum Ledger Database, for the use cases like systems of record, supply chain, registrations, and banking transactions. So that's all about the databases for today. There are many more database offerings also available. So we have discussed about the major offerings, and I hope you all have understood about all of them. And now you are able to plan and design the databases on AWS by deciding which database is suitable for your workload. So we will meet in the next video. Thank you.